Hey everyone, it is December 9th, 2020, and we are doing another Advent of Code. Advent of Code is an annual, every December coding challenge that lasts from December 1st to December 25th. A new coding challenge every day. We are doing this in Ruby because Ruby is awesome. We're doing this on stream because normally I get very distracted and I lose my focus, but we are on day 9, we are on a streak, and we're going to keep this going. So let's get right into it. With your neighbor happily enjoying their video game. If you don't remember from last time, we hacked the copy protection of a young child's video game console to make their life happier, and we fixed an infinite loop. We're just basically breaking laws left and right. This is the darkest timeline for this lore for sure. It's not pretty for anyone involved. With your neighbor happily enjoying their video game, you turn your attention to the open data port on the little screen in the front seat. Can I read? No, I cannot. The open data port on the little screen in the seat in front of you. Though the port is non-standard, you manage to connect it to your computer through a clever use of several paperclips. Upon connection, the port outputs a series of numbers, your puzzle input. The data appears to be encrypted with an exchange masking addition system. Xmas. Oh, that's cute for Christmas. Which, conveniently for you, is an old cipher with an important weakness. Xmas starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any two numbers of the 25 immediately previous numbers. The two numbers will have different values, and there might be more than one such pair. Okay. For example, suppose your preamble consists of the numbers 1 through 25 in a random order. To be valid, the next number must be the sum of two of those numbers. So 26 would be valid because 1 and 25 is in the sorry, I got distracted by the music there. 26 would be valid because it could be 1 plus 25. That's within the last 25. For the next or many other pairs, like 2, 24. 49 would be a valid next number, as it would be the sum of 25 and 24. 100 would not be valid. No two of the previous 25 numbers sum to 100. 50 would also not be valid, although 25 appears in the previous 25 numbers, so two numbers in the pair must be different. Okay, so we can't do 25 and 25. I actually missed that initially in the reading, so that's actually important. Suppose the 26 number is 45, and the first number, no longer an option as it is more than 25 numbers ago, makes sense, was 20. Now for the next number to be valid, there needs to be some pair of numbers among 1 to 19, 21 through 25, or 45 that add up to it. Okay. So 26 would still be valid. Okay, so I think we get the gist of how this would work. 65 would not be valid as no two numbers add up to it. 64 and 66 would both be valid as they would be the result of 1945 and 2145 respectively. Okay. Here's a larger preamble that only considers the previous 5 numbers and has a preamble length of 5. Okay, so we'll use this as our test input, and we'll have we'll write this out so it uses a variable list of things previous. That makes sense. That all makes sense. In this example, after the 5-number preamble, almost every number is the sum of the two previous 5 numbers. The only number that does not follow this rule is 127. Okay. The first step of attacking the weakness is to find the first number in the list, which is not the sum of the two of the 25 numbers previous. Whereas the number that does not have this property. Okay, so we're going to take this sample input, and we're going to try to make our program detect 127. Yeah, right here, 127. So we'll write a program that detects it based on this criterion. So let's start off. We're going to copy over this into day 9 because we'll use some of our basic input. We'll use our input lines function again. At a certain point, I should just like make that into a library, I guess. But no, we're just gonna copy and pasta until the end of time because this is all disposable throwaway code we don't care about. Okay, so next up, let's assume there's gonna be multiple samples here. So our input sample is going to be this guy right here. We're going to copy all this into here. And we'll check it against our actual input for the main thing to see if like there's a trailing new line or anything like that, because we want to be consistent. Nope. We chill, we good. Perfect. Okay, so we're going to get rid of everything except for our input lines, which is a function that we've written many times now, and it just opens a file, reads in the lines as an array, and takes off the new lines, because we never care about those. So let's actually just... let's make a little input thing that's going to take input lines and turn them into integers, because that's what we're working with here, right? We're always working with integers. And I think we're going to initially want this to be in a subroutine because we're going to be expanding this for a larger input with different variables here. So let's find weakness. We're going to call this the data stream. And what do we call it? Did they call it anything? Let's call it preamble length. And did they call this anything? They call it a data. They call it data. Which number you receive? I'm trying to... the preamble is the initial part that we don't care about. Trying to come up with a good name here. Port is non-standard. You manage the port outputs a series of numbers. That's not really a name. The data appears to be encrypted. We can actually just call it Xmas because that's the name of the protocol, right? There we go. So let's find our weakness here. So we already have an array of numbers in our input. So we're going to assume that this is at least input characters long, or else it's going to be at least a preamble length long, right? Okay, so now we're gonna raise if the preamble is wonky. We don't want that. Let's. So what I think we want to do is we just want to take Xmas and we want to start with the nth character, where n is like after the preamble, right? And then we just want to go to the end. Because we already did that bound checking. So let me just double check. So let's say we have an array that has A, B, C, D, E, F, G. Actually, let's do A is... actually, let's do one. to A. Ooh, that's a minus, that's not an underscore. Oh, I can't do a series of... Actually, we can just do numbers. Why am I... 1 to 100. Okay. I keep on not shifting properly. So, let's say the preamble is 5. We would want to start with the number 6 then, right? So let's say we're passing in 5. Oh, we need to cast this to array. Okay, I think that's what we're looking for here. So we want to go from... We're going to iterate, like how we normally would. Xmas, preamble, to preamble length. Each do. So we're going to iterate over each number going forward. Okay, so next thing we're going to do is we want each with index, actually. Let's do X. That's right, the index is going to actually be 0 at that point. That's really interesting. So that actually works out. So the preamble is actually going to be... So we're just calling preamble like everything that came before this that we're testing against. So preamble is going to be... number... We're going to be going from index to index plus preamble length. So example for when we're at index 0, when we're working on like so if we go back to this example here, where we have array, when we're at index 0, we're going to be at 6 because we're taking a little slice of this array that starts at index 5. That sounds really confusing. If there's any questions, I'm happy to answer them, but no one's watching, so that's fine. Because this is a slice. This is different. Actually, we can make this a little more clear, maybe. Postamble. Equals Xmas. Postamble, each with index, do number postamble IDX, and we want I don't know if that actually made this more clear or not, but we're rolling with it. All right, so we have our preamble. Now we want to get all of the sums from our preamble. So let's break that out into a new function. Okay, so we're going to take this array, we're going to do combinations. Combinations too. So what this is going to do is this is going to take all any two combinations that could possibly be in this array. We're going to do that. But we're going to reject when they're both the same. So we're filtering out those cases. And can I just do... Then we just do map. This is just an easy map operation. A, B, A plus B. So we're going to get every single combination we can possibly have. And there are things that we could do here. We could... If we thought, like, the array was going to be repeating itself a whole bunch, we could possibly memoize it or something, but I don't think that's actually important here. So now we have this thing that's going to make the sums of the preamble. Oh, this is spelled here. Index. There we go. Let's say sums. If sums none. Oh, we have to pass in the array into it, so we'll pass in our preamble. And so we want to find out if none of the preamble sums is the input. If so, that's our number. That's our girl. That's our dealio. And let's raise at the end. Too strong, not weak. So if we get to the end, there's no weaknesses. So we just get sad and we say, "Wow, what? There's no weaknesses. I'm very sad about this happenstance." Okay, so let's find weakness. I don't know if I actually like input as being a method there. Let's just do this. Equals input line. Okay, why am I retyping this? Make that go away, make that go away. And for our test example here, the preamble is 5 units long. Right? Okay, so if we run this, we should be happy, and we should have the 127 value. Or we'll get a syntax error. Oh, it's singular. It's not combinations. It's combination. I always feel like it should be combinations, so. Undefined local variable, sum. Oh. So when we're at this point, we actually don't have sum. Because that's limited to that block. Yeah. So we actually need to return number. Okay, perfect. 127. Okay, we're looking really good right now. So let's take our real puzzle input. Oh, I already had that open, didn't I? We'll just move this over here. Don't mind us. Shenanigans are happening. Give me my input. And then we'll driggity drag it. Oh, no. We don't have the browser open yet. The file navigator open yet. Okay, so let's... How big was this one supposed to be? First of all, let's change this into input. It might be valuable for me to change this to take an argument for file name, so that we can kind of like have the sample and the actual lined up together. That might be cool. That might be a cool thing to do for next time. We're not doing that right now, though. Or are we? No, we're not. No, we're not. So yeah, we changed that to input. And the weakness, the preamble is 25 characters now. Okay, let's go. Let's test this out. That's a big number right there. Is that actually in the input? Let's first find. That is in fact in the input. Okay, so here's the moment where we either feel elation or shame, because we're just gonna grip and rip. We're gonna go hard. We're gonna just press this button, and if we get it wrong, we are gonna be in a purgatory of 1 minute timeout, and there is shame there. We don't like shame. Shame is bad. But we're gonna be victorious. We're gonna be victorious and proud and soar like an eagle, and that's what we're gonna do. We're gonna hit it. And we are correct. We gathered another gold star. I feel flashbacks to my elementary school days where doing things like brushing your teeth and stuff like that would give you a little gold star. And I don't know, did everyone's parents do that? Mine did that. Okay, so now on to part 2. Jubilation can only last so far because we have work left to do. The final step in breaking the Xmas encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list which sum to the invalid number in step 1. Okay, I'm not sure exactly what that means quite yet. Contiguous means consecutive, right? Contiguous? Contiguous. Touching. Yeah. So they're basically consecutive. Yeah. You must find at least 2 numbers consecutive in your list which sum up to the invalid number from step 1. In your list, does that mean like the entire input? Okay, so we're back in our list. Is this the sample input again? Yeah, this is the same sample input, I'm pretty sure. In this list, adding up all the numbers 15 through 40 produces the invalid number from step 1. Of course, the contiguous of numbers in your actual list might be longer. Okay, so we don't know the length. Find the encryption weakness, add together the smallest and largest number from this range. For example, these are 15 and 47, producing 62. Okay. Okay, this doesn't sound hard. This doesn't sound hard at all. I'm confident that we'll be able to bang this out real quick. So let's make a copy of our source for part 2 of this expedition. And we'll open up part 2 as well. So we'll switch back to sample mode. Sample A. And we're back to doing 5. So we already found the weakness. Do we need the weakness and the index? Does it need to be before the bad number, maybe? I don't know. Yeah, here we go. Here we go. We're already halfway through it, Baka. You're here for the hard part now. Although I don't think it's gonna be that hard. So to recap, what we're doing so far is we're just going through, and we have a sequence of numbers that possibly we have a sequence of. Yeah, sorry, you missed the easy part. That's fine. That's fine, dude. We have a sequence of numbers. In our actual problem set, it's longer. So for this problem set, because it's shorter, every number has to be the sum of a random 2 numbers from the previous 5. So 40, that's going to be that's going to be somewhere in it, that 2 of these numbers are going to add up to 40, right? But there's exactly 1 number in this set that doesn't match that. So part 1 was being able to identify the one that doesn't match that. Now what we do, now we know the number that's wrong, there is a set of 2 or more consecutive numbers, contiguous numbers, numbers that are touching each other in this sequence, that add up to our mystery, to our bad number. And we need to identify that, and we need to find the smallest and largest of those. So we get to run largely off of our initial problem set. We get to borrow a lot because we basically we still need to find the weakness, right? We need to find the weakness in the algorithm. So in this case, the weakness is 127. So we're going to write some code right now to make sure that to find where in the set what contiguous numbers add up to 127. That should be pretty easy. So we're going to make a little another method. Do I actually want to use the word contiguous? And this is going to return an array. In this array that add up to some. So this is going to be kind of like brute forcey. So it's not going to be like this is not going to be an elegant solution. Don't get me wrong. This is not going to be an elegant solution. So we're going to actually let me grab in our weakness. We'll put our weakness. So let's take so we need the size of Christmas. We need the size of Xmas, right? Try and think how I actually want to do this here. So what we can do is we can actually iterate over each index in Christmas, and then go there and forward. And if it's ever above some, then we know we went too far. If it equals some, then we're good. So let's start off with this. Each with index. Num. Start IDX. current sum is 0. We don't want to override our parameter telling us when we actually want to stop here, right? And so now what we just do is we just do xmas I think here the first start index is going to be 0. Let's do start idx plus 1. And so we're just doing a slice of Christmas from the current index until the end. Each do inner num. Inner IDX. Oh, we don't actually need the index here. It doesn't really matter where we are in the inner loop. We're just churning along. Also, I don't know why I'm doing camel case here. That's not how you usually write Ruby. Cool. So we know that it has to be at least 2 numbers, so we're never going to be satisfied with just starting with the current number, right? That's never going to be okay. So it always has to be 2 or more. Oh, the old one had a requirement that things can't be that the numbers have to be unique. Is that a requirement here? You must find a contiguous set of at least 2 numbers, and your list which sum to the invalid number from step 1. Consider the following example in this list. Adding up all the numbers 15 through 40. Okay, that blah blah blah. That doesn't matter. Of course, a contiguous set of numbers in your actual list might be longer. Okay, that's totally fine. It probably will be. To find the encryption, add together the smallest and largest number of the contiguous range. Okay. So we don't need to worry about uniqueness here. Before, when we were trying to figure out what was like the weakness, we had to add together 2 unique numbers. So if the number 25 showed up twice, we couldn't add them together to get 50 as a when figuring out the weakness. Okay, perfect. Let's move on. So we're going to be adding on to current sum. Internum is such a terrible variable, but we're running with it. Oh, and we need to keep track of these, don't we? We do. We definitely do. Let's see here. 1, 2, 3. And we can just call sum on this, right? Yeah, we can. Okay. So this actually gets a little easier. It's a little more wasteful, but it's also going to be a little cleaner, I think, to look at. So we're going to, instead of keeping a memo of what we're summing, we're just going to keep an array of sum to numbers. We're going to add on inner num each time. And we're just going to cache that right there. If current sum greater than... Okay, so for starters, if current sum equals the sum we're looking for, return summed numbers, and we're happy. Otherwise, if the current sum is greater than the sum that we're looking for, we break out of this loop entirely. We don't need it. It's dumb. It's so terrible. We don't need this loop. Forget that loop. And we're gonna break out of this loop, and we're gonna end up back in this loop here. I really hate using flow control like this, so that I might, as a refactor, might want to move this entire loop into its own function, but we're going to keep it for now and see if this works okay. We don't need an else, because otherwise we're just continuing with the loop. We need to end this, or else we're going to be really sad that's not going to compile then. So ideally, we return something. We return the summed numbers. If we aren't able to do that, let's raise an exception, because we're sad, and we're sad. We couldn't find a sum that matches sum. It's a very disappointing happenstance, and we fail, and probably it just means that we have an error because we know there's a weakness. We know there's a weakness, we know there's a sum because the problem told us. So okay, so let's do find contiguous sum. And we're passing in Xmas again, and we're passing in our weakness. Let's pre-print it this time because we're getting an array, we're getting an advanced structure. Let's pre-print that, and let's see what sort of errors we have right now, right? Problem O2. Okay. So let's look at the examples here. So we do know the answer to this already. Adding up all the numbers 15 through 40 produces this invalid number. Okay, so that makes sense. Actually, we're not finding the sum. We're finding the summers, right? Oh, this gets nice, right? It's a play on words now. It's seasonal. We have any summers in the chat here? Okay, that's enough with that silliness. Let's rerun that, make sure that I renamed it, didn't break anything before we move on. Okay. So now we know summers is this. Min. Max. Oh wait, actually I need to sum those up. Sum min. Summers min. Max. Let's make this prettier looking. Summers. Little tab action there. Some min, some max, and some sum. The min plus some max. Just doing a little formatting here. Okay, let's see what this gives us now. This should still be running correctly. We expect to see the number for sum min, we expect to see 15. For sum max, we expect to see 47, I think. And some sum should be 62. Okay. Yeah, that's exactly what we expect. So now it's time to just change our input up. Change our input to our input main. To do it on the real puzzle. And we adjust our weakness here. So if we did everything right, this should just work now. We've done some testing as we've gone through, so I feel pretty confident about this. Okay, so we got a value. We did not hit any of our exceptions. That's really nice. Just as a sandy, part 1 was this 279111008, so we're consistent there. So this sum, it could be the end of the problem. It could mean our jubilation. It could mean that we're done. It could mean that we're just enjoying life and we're finished with this. We just hit submit and maybe we're done. Maybe we're victorious. We do a lap of victory and bathe in the glory of a job well done. Or we have shame. Shame is the alternative. We could end up in the timeout of despair and just feel terrible about ourselves and be stumped as to what to do next. And this short 40-minute stream turns into a 3-hour stream where we're just pulling out our hair and growing older every minute, not sure how to proceed in life, and really unsure how to reconcile ourselves in general. So you can't live in fear. You have to embrace the future, and that's what we do. We do this right now. We do right now by hitting submit because we're submitting to destiny. And we're right. We get another gold star, and we win this once more. So that was not bad at all. That was it was a little brute forcey. We're having some brute force problems. I don't know if there's a sexy better alternative, but you know what? We take these. We take these, we win these, and we feel good about ourselves. So that's all the content we have for today, sadly. So thank you so much for hanging out. Make sure to check out the Twitter. Make sure to drop a follow. Make sure to check out the YouTube where these VODs are all going up. And maybe extra content ends up there. Who knows? It's a mystery. And also join the Discord. That's where you get pinged every time we do new things. Every time stream fires up. And it's not all coding. If you're not like someone who's like, hey, I want to see people code all day, you know, we'll do other things. We're gamers too, right? So thank you so much for hanging out. I hope that you have a great evening. And I'll catch you all next time.
My head